Okay, okay, okay. So third method which we are going to discuss it now, it is EMF method. Sorry, ZPF. Okay. So I already explained one is EMF method, another one is MF method, third one is ZPF method. This EMF is nothing but electromotive force method. It is other name called as synchronous impedance method. And MF method, its other name called it as ampere turn method, which is applicable in magnetomotive force, which is applicable in the winding. And third method, it's known as ZPF method. These three methods, okay. This ZPF method is other name called it as Pottier method, okay. Pottier method, okay. This all these methods you are going to do in your lab, okay. This is experiment number uh, 7, 8, experiment number 9, experiment number 10. This is very important. Okay. So these first two methods are already completed. Now I am going to explain zero power factor method. This zero power factor method is other name called as Pottier method. Okay, what is mean by a zero power factor method? This zero power factor method is used to determine the voltage regulation of synchronous generator, okay, of synchronous generator or alternator. This method is also called as Pottier method. In the operation of this alternator, the armature resistance drop IARA and the reactance drop is actually will be equal to your armature reaction quantity. For example, this is the winding. Okay, this is a coil. Actually, this is a coil. This coil is having both resistor and inductor. Okay, the voltage drop across this resistor will be I into R. I into RA. The voltage drop measured across this reactance, across the inductance will be I into XL. Okay, leakage reactance. Leakage reactance. Understood or not? As well as this ZPF method is based on the separation of armature leakage reactance and armature reaction. Okay, armature reaction. Okay, this is one of the important type. Okay, for one more question. The ZPF method is based on separation of armature leakage reactance and armature reaction effect. Armature reaction effect. Armature reaction effect. Okay, so here also there are two tests which we are going to perform. One is same open circuit test, another one is short circuit test. Now see, you see the diagram. This is a diagram of this ZPF method. There are armature winding. Okay, this is the stator winding which is connected in star connection. Star connected. Okay, star connected stator winding, and this stator winding it's connected with an alternator. It's to measure the field. There is a field will be there. We are giving DC excitation. This is a rheostat. Okay, this is the rheostat, and here there will be a inductive load. Okay, we are operating inductive load for separating inductive load. We are operating to separate the leakage reactance. Leakage reactance means it is IXL. Okay, current into XL. Leakage. XL stands for leakage reactance. Now the operation is very simple. Now the switch is open. Okay, this the switch is open. The alternator is moved to run at synchronous speed. Okay, it is running at synchronous speed ns. Okay, and this speed will be a constant speed. Now we have to giving a field excitation to your field winding. Now this excitation value will be changed by using this rheostat. This rheostat is nothing but it is a potential divider. Okay, in our laboratory we are using the rheostat, or we can use decade resistance box also. Potential divider. The other name of rheostat is potential divider. Okay, so by varying this potential divider, we are going to measure the voltmeter and ammeter readings. Understood or not? So here we are plotting the value IF in x-axis, field current, and VOC, open circuit voltage, in y-axis. So this IF we have to measure in field winding by using the ammeter. This VOC we have to measure in the stator winding. Here we have to measure. Okay, stator winding we have to measure it. Okay, then zero power factor test. In zero power factor test, we have to close the switch. Okay, so when you close the switch, there will be a inductive load which we are connecting to the alternator. To measure the current, we need an ammeter. Now in inductive loading, we are setting the power factor value of 90, cos 90. Okay, cos 90 power factor. This is a power factor which is setting, that is which is equal to 0 power factor. 0 power factor lagging, because if power factor is 0, that is cos 0 will be, what is power factor 0? How much? Cos 0, cos phi equal to 0 ma. Cos phi, it is 0 power factor, cos phi equal to 0. So how much phi value? Cos inverse of 0, cos phi equal to 0 ma. This is power factor, 0 power factor test. Cos phi equal to 0. So phi equal to cos inverse of 0. Cos inverse of 0 will be 90 degree. Okay, so this 90 degree only we have to set. Understood or not? Understand or not? 90 degree. Understand or understand this point? And here in this method we are setting the synchronous speed. Ns is equal to 1500. It is a constant speed, which is the constant speed. Now the load current delivered by an alternator to purely inductive, which is maintained constant at full load value. Now by varying the excitation, we are going to vary the load. By varying both load and field value, then we can get a 0 power factor. Okay, this is the 0 power factor line. This is the line, and here you are getting a triangle symbol. This triangle is nothing but, you see, by varying the value you are getting a open circuit characteristics. This is the curve. Okay, and afterwards in 0 power factor test, by varying this excitation for every time, because when you do this experiment in the laboratory, you will clear about this diagram. Okay, this is my Poitier triangle. Okay, this is nothing but this is Poitier triangle. Poitier triangle. Okay, this is nothing but Poitier triangle. This triangle will be formed for every excitation. For every excitation by using the load. By using inductive load. Okay, by using inductive load. Okay, the theory which is available here, please go through this one. Okay, please go through this. And this is one 10 mark question theory. Okay, in your examination if we ask, please draw this graph and explain this theory. Okay, the points are given, please explain this theory. Okay, the formula, everything will be similar. Okay, now what are the assumptions will be taken place in this method? Here we have to neglect the first assumption. You have to neglect armature resistance. Okay, this is my first assumption. Armature resistance you have to neglect. The second assumption, you have to set zero power factor test. Okay, so these are the two assumptions which we are made in this Pottier method, that is nothing but zero power factor method. Okay. And now I'm going to explain a simple concept, that is nothing but if parallel operation of alternator. Parallel operation of alternator means if two alternators are connected in parallel. Okay, you know the concept of series and parallel. Series and parallel. In series connection, this is a connection. Okay, the 2 points are connected in series. In series connection, the voltage is same, current is different. Sorry, voltage is sorry, the voltage will be different. Okay, in series voltage is different, current is same. But in parallel, this is my parallel. Okay, the voltage will be same in parallel connection, current will be different. Okay, now this parallel operation of alternator which is applicable in power stations, power systems, or we can say it will be a power stations, they are operating it. Where they are operating, only they are operating in generating stations, in hydro power stations, or thermal power stations, or nuclear power stations. And what are the conditions of parallel operation of alternator? This is one 6-mark question. The major condition of alternator is the process of connecting two alternators in a infinite busbar system in parallel. It is known as synchronizing. Okay, synchronizing means it should be unity. Okay, it should be unity. For example, this is one alternator, this is alternator 1, and this is alternator 2. I am connecting in parallel. I am connecting in parallel. Yeah, it will be a common voltage we are applying. I am connecting in a parallel. So the current is flowing differently, but the speed, okay, the speed between these two ns should be same. Okay, this concept is known as synchronizing. Synchronizing. And the running machine of the machine which carries a load, yes, load should be must. And incoming machine of the alternator which is connected, yes, incoming machine means the input voltage we have to connect it. What are the conditions are there? There are 4 conditions are applicable. One is phase sequence of the incoming machine, voltage and bus bar should be identical. The RMS value, that is the root mean square value of the bus bar, should be same. The phase angle means 60 degree or 120 degree, it should be equal. The frequency 50 hertz should be same. Okay, so these are the conditions of parallel operation of alternator. What are the conditions? The first condition will be phase sequence. RYB should be same, and second one will be the RMS value, line voltage should be same. Third one, the phase angle should be same. Fourth one, the frequency of the two terminal voltage Fs equal to 50 hertz should be same. This is a condition of parallel operation of alternator. And procedure. You see the diagram. This is my generator 1 and this is my generator 2. This is a load. Okay, so this both the generators are connected with a machine. This is a switch. Okay, so to make the machine by using that general conditions, we are operating it. And this diagram which should be applicable in power stations, in generating stations. Now when you operate it, when you switch on this supply, that is when you switch on S1, automatically this generator 1 will be connected in parallel and it will be operated. Okay, parallelly it will be operating it. The both the speed will be operating in a parallel. Now my concept is very simple. Now tell me the answer. Now I am taking a bulb. Okay, this is my filament bulb, and this is another filament bulb. Okay, now this is connected in parallel, voltage you are giving. Okay, current is 5 ampere. Okay, it is meeting in this junction, and it will be here we are getting 2.5 ampere, here you are getting 2.5 ampere. Now my concept is very simple. Here, if these two bulbs are connected in parallel, now what happened to my brightness? The brightness will be same or different. Can anyone tell me? If two bulbs are, what about the brightness? Brightness?
Same, sir.
Yeah, it is same. Okay, it is same. Now where this connections it is applicable, this parallel operation, yeah, it is applicable in our house also, in our domestic applications, in our domestic wiring lines. All the connections are in parallel. Okay, which is applicable, not only applicable in power stations, it is applicable in our domestic lines also, but based upon our specification of our home appliances. But in hydropower stations, they are generating the power at a constant speed. So if they connected two generators at a time, they can achieve a maximum level. Okay, so that's what this parallel operation is applicable in hydropower stations. Understand? Hydropower stations. Okay, thank you. Okay, any doubts? Any doubts, students? Have any doubts? Any doubts?